propulsion system. So the Chevy Cruze that we just showed in Paris has exactly the same wheelbase than what you see in here. And the propulsion system would also theoretically fit into this vehicle. It's a very important piece also to bring the cost down, because when it comes to front suspension, rear suspension, steering systems and everything, you want to use components that are manufactured in millions of units per year to really bring down the overall cost of the vehicle.
What is it cooled with? What are the batteries cooled with? What is the liquid?
It is a specific liquid defined. There's a specification for it because it has to fulfill certain conductivity requirements. We can provide you with a specification. It has been already 10 years ago. There was a specification for that liquid. It is nothing very special. It only has an additive that deals with the conductivity, but it's in principle water plus an additive. It is nothing very fancy.
All right, quick question. What's that little object in front of the wheel there that's not labeled? Yeah.
Charger?
Yeah, the charger.
This is the charger on board. Completely flexible, deals with 120, 240 volt, has between 1.2 and 3.3 kilowatt. So this is handling all the charging on board. So it deals with a standard outlet that you have in your house, but it also deals with a higher current level that you have in your house. This is the charge port going to the charger, going back into the battery.
Could you comment on the state of charge that it would be used in the battery?
Actually,
the window.
What I do is I show you how the car is being used to explain how we use the state of charge. If you could run this for a moment, that we are clear how the operation in the vehicle works. So let's go to the charging. The car is empty and the battery is empty. You are charging it, you are plugging it in to the charger, and you are filling the battery. It takes on 240 volt less than 3 hours actually to get a full charge in the battery. In the first 40 miles, you have a pure electric drive. You don't need the engine at all. It will not come on. It goes to the power electronics, and you see the front wheels being propelled to the electric drive unit. Now you are braking, you are charging the battery in your braking process, and then you are just emptying the battery. Once you are emptying, the engine will start running and generate electricity, and together with a buffer zone in the battery is providing exactly the same power level. So the car will have it is absolutely consistent. Whether you have engine-generated electricity or power coming from the battery, it will be a consistent performance that you see in the vehicle. We would never accept actually that you see a different vehicle performance. This is how it in principle works. What it also means when you go and saw how we are dealing with an engine that is generating electricity, you always have to make the assumption that you want to arrive home empty. It means we are not charging the battery while you are running, while the engine is running. So you cannot assume, okay, I have the vehicle parked there, I let the engine run and I charge the battery. No, the car, we don't want to burn gasoline or ethanol to generate electricity on board. It is much, I think, environmentally and economically, you want to arrive home empty to plug it in and get the electricity from the grid, not from burned gasoline in a vehicle to generate.
Think about functionally, let's say the moment I'm running out of charge and now the internal combustion engine starts working. How does that process seamless?
It's for you.
Is there a transmission that regulates? Or?
No, it is what we have. Actually, the electric motor and the generator are in one housing connected to the engine. For you driving this vehicle, it is completely seamless. It's just you then hear an engine running at low RPM starting to run. You have a transition, but for you, you will have a little display coming on that now you are changing from battery mode into what we call charge sustaining mode. So the engine is running. But for you, it doesn't make any difference.
You don't feel anything physical. You just hear the engine.
No,
no difference in performance.
No difference in performance. We are working to minimize the noise that comes from the engine. We are also in the mode where the engine is generating electricity. We are different to any hybrid vehicle because we don't have to follow the load that comes from the accelerator pedal. A hybrid vehicle, when you actually drive hybrids and you get actually wide open throttle room, you can see the engine moving. We don't have to do this because of the large battery. We can decouple your accelerator position and how you almost calibrate the engine. It is very important to understand that when you are generating electricity, you can generate and use the engine very efficiently because you run it at certain best points on the fuel map where the operation of the engine is very efficient. And this means also while you are burning gasoline to generate electricity, that the vehicle is actually very efficient in its operation. Now, come back to the question, what is the band exactly of the battery? This is proprietary information, we don't talk exactly about it, but what you see, to protect the battery for 10 years and 150,000 miles, you cannot use this battery like consumer electronics. In consumer electronics, you basically use the full available energy and you destroy batteries within 1, 2, or 3 years depending on how you use them. In a car that is absolutely not working. So a usable amount of that battery is roughly half of the total available energy in the pack, and this is a way how you can protect that battery for life.
But the way that the engine transitions automatically protects it for you. So from a consumer standpoint,
Yes,
okay.
yes,
You don't have to worry about it.
No, it's nothing you have to worry about.
You don't even have to think about it.
No,
Right.
it is, you are not involved in that process.
Okay.
The engine will start, and either you come home empty, you refuel the vehicle. It is nothing. What we clearly learned from electric vehicles, people don't want to design their life around the vehicle needs. They just want to be able to drive and either fill it with gasoline or plug it in, but it is nothing that you can spend a minute on where you arrive and how you charge it or how you get fuel in the car. People would not accept this. And when you look at the volume potential, this is one of the reasons why an extended range electric vehicle, we believe, is really the only true technology that can make it into high volume, because you create independence from petroleum because you plug it in the majority of time, but you don't create any range anxiety or anything that is constraining you in the daily usage of that vehicle. And now people will come back and say, yeah, but you're not all electric. I make a statement about this also. The battery that you see in the Volt is 16 kilowatt hours and providing 40 miles of electric range. So in a normal car that has all electric range, you probably would expect something that at least has 200 miles of range, which means 5 times the battery. This is 400 pounds of battery mass. I don't want a 2,000 pound battery to drive this around with me. It is never affordable. And no battery improvement of the future really makes this a viable option. So therefore I'm saying is batteries and pure electric vehicles will exist for a certain purpose with limited range and when